Hello, Ripple folks. This is Ron, or Karma Coverage on the forum, and I wanted to follow up with a video about the internal topology of the XRP ledger. When I was discussing with Erie the topology of the international monetary system, that's important, but I want to show you what you're purchasing when people say XRP has utility value. What is that utility? So as I was discussing with Erie, a lot of these network companies like Google, railroads, Facebook, etc., Twitter, effectively what they do is they build a network and then they help you route whatever the network is moving through there. So the utility value of XRP and what you get when you pay and you burn that XRP for your transaction is you're using the pathfinding function that's built into the XRP ledger, and that effectively finds the cheapest route for your liquidity, for your value to move through the network. I'm mostly going to focus on trust lines and order books. I'm not going to get too much into the details of either. I just want to try and draw a little picture and drive home the point that there's a whole network inside of the XRP ledger. And that's what I think makes it a standout network as compared to most of the other cryptos. So let's see here. This might get a little bit messy, but I'm going to do my best, and bear with me, I don't have the best handwriting. So I'm going to make a couple of wallets here. So we'll have an A, we'll have a person B, we'll have a person C, we'll have a person D, and a person E. Now, anybody who's been paying attention to the some of these airdrops, oftentimes these require you to set a trust line. So what you do when you set a trust line is A basically says, hey, I trust B. And so let's have C say, you know what, I trust E. And then D. And we'll make a connection here too. So now, let's say that A wants to send a payment to E. Well, part of what pathfinding does, when I say it finds the cheapest path through the network to route the liquidity, is it looks for the what's called the lowest quality or minimum quality. I forget what they call it in the code, but effectively, well, let's also say that we've got a connection here between D and E. So pathfinding function is going to say, hey, A wants to send $1 to E. Well, they don't obviously have a direct connection, but the liquidity and the value can flow through B, and then it's going to get to C. Okay, now the pathfinding function has an option. It can either go the route straight from C to E, or it could go the route from D to E. And let's say that C has a cost associated with this trust line connection. Could be a quality out. And as it turns out, instead of routing the money through here and paying, let's say a negative 1% fee, it's cheaper to route the liquidity around here. So when you pay that XRP that you burn for the transaction, you're paying for this decision to be made on your behalf. And so that's kind of, I'm going to leave it there with trust lines for now. I'll probably do another video on trust lines down the road. Now, order books are another major type of ways to connect value so that it can flow through the network. So let's say we need some order books here. And all of this is going to be inside the XRP ledger. So this is all, XRPL, whatever. Okay, so we need some order books. I'll make them red. So we've got an order book here, and let's say that C issues an asset, and then we'll just have A issue an asset. And so we've got a very, if you want to trade A for C, then there's a direct order book. But let's say we also have an order book between A and XRP, and an order book between C and XRP. Now, you have two different options. Let's say you want to trade A for C. Well, you can either make the connection here directly on this order book, or you could trade A for XRP, send it over to this order book, and then trade XRP for C. So two different ways you've accomplished the same thing. But notice how many connections we have inside the ledger. Now, let's say you have another order book over here with some obscure asset issued by D. So you've got D over here, but D has an order book between XRP. So now you have a user A, or a holder of this A asset here, and let's say they for some reason want the D asset. Well, there is no direct order book between A and D's assets. There's no direct link at this point. But what we can do, and this is called synthetic order books, and then I think they started calling it auto bridging after that. So you can take the A asset and shift it over to this order book, flip it into XRP, flip the XRP over here, then you can trade it for D, and then A can get their D asset. And it would be really nice if somebody could make some graphs that would show the actual trust line connections and like the internal graph of the XRP ledger and the order book connections, so that we could pull up a live graph and show everybody just all the connections, because it's a dense network, and the more of these connections, I think obviously the network becomes more valuable. You can route liquidity to more corners of the world, and this is why ODL is important, to be hooking up to different, in the international space, to different economies. But I would think going down the road, as the XRP ledger grows in value and adoption, that a metric and a graph, a way to view the graph of the XRP ledger and all the connections and watch the density grow, would be an extremely valuable metric for anybody who's trying to, say, assess the value of XRP. And let me flip this back up. And so I think that for somebody maybe like, well, I don't want to name any names, but for the people who are more inclined and skilled at the graphics design, I think that depicting these connections shows the increasing value of that pathfinding function. And when you make a payment or a transaction on XRP Ledger, you're paying for that pathfinding function to find the cheapest route through the entire network for your payment. And that's important. That's the key to XRP's utility value. So I hope that helps. If you have any questions, please let me know. Again, I'll do my best to answer.